Hey everybody. So one thing I wanted to do today is to try to spend some time um, working on the pending MCPs, which I'm now trying to rename to project proposals because so many people seem to get confused about compiler versus lang team MCPs. I'm not sure if that's the right move. Maybe people are bound to get confused no matter what, but anyway, I wanted to look over some of the ones that are there and see if we can't kind of give feedback to the people about whether they're realistic or not. And we also have a few pending group charters that we could talk about. But I guess let's get to that when the time comes. I don't know whether I want to do that first or skim through the other stuff quickly and leave time for it. I think I would be inclined to do that because we could spend probably a lot of time on it potentially. So I reorganized the project board, by the way, to try to give it a little more notion of staging, but also so that early things are like more stable and later things are less stable. Which reminds me that actually we don't have a meeting scheduled for today right now, for this week right now, as far as I know. We could schedule the stream trait discussion, or we could leave that for next week. I don't know if I have an opinion, except that it's a little bit short notice. Maybe better to leave for next week. But
would the related issues there include some of the discussion about integrating that into for loops?
Maybe, yeah. I had planned to go over sort of what is being proposed and what are some of the forward compatibility implications, like things that we have to resolve in the future if we go this way. And that would include covering like for loop sugar and what that might look like and so on. Why don't we push it for the week after this? So that we can ping like boats and everybody else and not be like, hey, in 2 days. Also, I know that Nell was going to do some more work on the RFC this week, so maybe that would be a good time.
It would be nice if we could get Boats, Taylor, Nell, and other stakeholders there, yeah.
So why don't we ping and say, we were thinking of scheduling this for, that would be the 12th.
Yep.
I forget, I think that's it. And Yash expressed interest to me before.
Good call.
Okay. So, all right, we'll do that. Let's see. Then I guess I'll go back. I'm going to skip over these incoming proposals for the moment. Oh my God, this thing is driving me crazy. Sorry, I have to resize my window or something because it keeps being annoying. Okay. In terms of active design, I don't think there's any const evaluation updates, right? Doesn't even know of any. But I'm gonna assume no. Async foundations, the main thing is ongoing work on streams that I'm aware of. For safe transmute, I think they're still working towards the RFC, right?
I saw a PR for a draft RFC or something. So I think so, yeah.
That would be interesting. I think it was on this repo. Maybe I'll throw in a link.
I think it was the project repo, yeah.
Might be worth, be nice if we somebody for like a brief summary. But maybe next time. Okay, that's cool. FFI unwind. So we're now in the implementation state. I merged the RFC last week. And I think we have a potential person who will work on the implementation. So that's cool. So I'll probably move this. I'll just keep giving verbal updates, but I don't think unless there's any like, oh, I have to move this over to implementation. I think the implementation category tends to not have a lot to say, but some of these are the fallback. So there's still ongoing work there with Blitzer, which is good. This was basically stalled. I don't know. We might need another category for this stalled stuff. But there you have it. Evaluation, no new updates on inline assembly. I assume we're still just kind of waiting for people to use it. Right?
Right.
Okay. And raw ref macros, maybe else done a stabilization report. Maybe not. I forget. Oh, right. We're waiting for people to click their boxes. That's what's happening. Those of you whose names are not checked here, consider going and checking yourself. That's all our public reports. Let's close all these tabs so my computer goes faster. Any comments or anything? I'm going to stop my video because my computer is kind of dying. Maybe that helps sometimes. Okay. High issues. Nothing new. Common PR. Got some. We'll start with this one. CFG panic is ... Right.
Yeah.
Okay.
This was one of the ones that seems remarkably simple in terms of this doesn't seem like it needs a full project group or similar. This might be doable with just a PR.
Mm-hmm. Okay.
I think the obvious question is there any reason or objection that we don't want to make it possible to do configurable compilation on the basis of what your panic strategy is?
Yeah, and no one said much about it. So the exact motivation is tests.
Well, tests is one proposed motivation. There are also, if you have a library that you expect to be able to use catch unwind, then it's going to be very unhappy if it builds with panic abort. So you may want to do config not config panic equals unwind and give a compile error.
I don't see any reason we wouldn't want this. One question I have is, do we want it feature gated in some way? 'Cause
I
think
mean, at least initially for a release or two, probably, just because everything is, but I doubt that it will be particularly surprising.
yeah, so the PR is insta stable, so we should probably suggest revising that. I'm also not too comfortable with that if we can avoid it. I don't know how hard it is.
Not too comfortable with insta-stable or not too comfortable with feature gates?
Insta stable
Okay, that's what I thought you meant.
in general.
Yeah, same.
Every time I think, what could possibly go wrong? All right, well, someone want to RFC bot FCP merge, I guess. With that
Well,
cut.
I think we should ask for the feature gate first, unless you want to do an FCP merge and then a blocking concern.
Well, sure. I meant write a comment, expresses the concern, and
Okay.
I think we could merge it with a proviso that this assumes that it'll be merged with a feature gate.
I'll take care of writing up a comment. I'll write an FCP merge and then immediately file a concern for needs feature gate, just to make sure that we actually check that that happens before it gets merged.
Okay. Alrighty. Before I move on, any further comments? All right. So the next one, make const evaluatable more strict. Do you want to talk about this? LCNR? I don't know if I know your real name. Bastian? Or...
I don't know. I could explain what's going on there, if it helps.
Might help.
So right now we check that all array expressions are concrete, so we do not allow any generic expressions like size of. These are forbidden. But we currently check this by simply evaluating the expression. So the most important thing is size of pointer to t has a known size, so that evaluates successfully even though it mentions t. And the example given here with foo currently evaluates because Miri only sees size of pointer to t and does not check that this function might also call size of t, which is concerning in my opinion. So would like to forbid it.
Yeah, there's probably. Have we finished a crater run on this?
It's currently running, as far as I know.
Okay. I think it makes sense to discuss until, or should we just wait for that result? I guess, does anyone have any thoughts or concerns about this proposal? It's only recently stabilized, it looks like. The behavior in question, like you said, it was introduced 2 versions ago. How do you propose to make it more strict? Like, what is the new behavior that this PR implements?
So the new behavior checks right now anonymous constants have to, let me quickly check. We add a flag right after mir build, which checks if the mir needs any substitutions. which seems to work well, from what I can tell.
It's kind of the
But-
polymerization check we were talking about earlier, like you're checking kind of, could it potentially be polymorphized? Is that?
And when using associated constants, we simply check if all subs are fully concrete,
Okay.
as far as I know.
We'll have to wait to create our results before we say anything more, I guess. Unless there's more comments. Somebody's honking. All right. Any final comments? Then I'll move on. Nominated issues. None. Hooray. Nominated RFCs. 1. So this RFC, for those, I don't know why it was, who nominated it and why. Maybe it was even me. I don't know. I remember us talking about it semi-reasonably. Oh, Josh did, okay. I see. So this RFC says that, proposes that if you have an unsafe method in a trait, you should be able to implement that trait with a safe function. And the implication here is that the only meaning of safe is that you've got that the caller has potentially extra safety criteria that they must meet, and not, for example, that the callee must meet some post condition that sort of makes it unsafe to implement. And I think that's what Josh wanted to talk about. Is that right, Josh?
That's right, yeah. So the proposal, it's exactly what you were just saying, that the proposal was that you don't have to write unsafe if your function body doesn't need unsafe, even if the trait declared the method as unsafe fun, which that, first of all, I think this is related to the thing we've been discussing more recently of an unsafe fun in general shouldn't necessarily make its body unsafe. And I think that partly addresses this in that the body of the method will not be presumed to be unsafe even if you do write unsafe fun, so that you don't have to you don't accidentally use unsafe if you didn't want to. But that aside, it yes, exactly that one.
Yeah.
So that aside, I feel like there's a different concern here, which is suppose you defined a trait with an unsafe fun, and the reason it's unsafe is that when you call it, you are expecting the callee to meet certain requirements, and if the callee doesn't meet those requirements, then the caller is going to explode. So, you know, pointer must have a certain valid value, or this, you know, this set of constraints must be met within this data type that it's constructing. Take your pick. And if that is valid, if that's something you're allowed to do, which whether it's allowed or not, it's something that people widely do. I have seen a number of examples where people define traits where their methods are unsafe because of this. And so what I'd like to know is how would that interact here? If you defined a trait with an unsafe method, you would suddenly be able to write safe code that, because it doesn't meet the expectations of some other code elsewhere, would cause some kind of breakage, and you never had to write unsafe yourself.
So I thought that if there was an expectation on what the implementation of the trait would do, that was an unsafe trait, not an unsafe method on the trait.
That's a good question. Is that what that's supposed to be?
That is
Because I
definitely-
thought that an unsafe method was that there are preconditions that are not checked by the type system that the caller must uphold, but that
I
the
see.
method itself always has to do sound things based on the preconditions that it knows about, either because of the type system or because they were in its safety section and the caller promised to uphold them.
So the theory then would be if the callee must meet certain requirements, then the trait should have been defined as an unsafe trait requiring an unsafe impl. And
Right.
unsafe fun means the caller is prepared to meet requirements and call this an unsafe block because so it's allowed to do unsafe things. But if that is the case, okay, I see what you're saying. If it were just that you want to do unsafe things, you could use an unsafe block inside a safe fun. This is the caller needs to meet certain requirements in order to call the function, so it's an unsafe fun, so that you know you have to write unsafe around it and you have to meet its preconditions. But if you have expectations of the function, it should be an unsafe trait.
Any of those extra preconditions, like you've decided to implement it as to do,
so
then you don't depend on any of the safety things that the caller is promising. So you could mark it as not unsafe because there are no non-type system prerequisites, preconditions that the caller needs to uphold.
So I think that the language is, Scott's understanding makes a lot of sense. We've kind of sometimes considered the opposite. I think the main example that comes to my mind is the trusted length method. But I think in the end, well, let's take a look.
Isn't trusted len an unsafe trait though?
I think we deliberately made it an unsafe trait because we didn't want to endorse the interpretation, like so as to leave room for this interpretation. You know,
It's also nightly only, so it is something we could change if we needed to.
Yeah,
right,
I think trusted len is also interesting here because there is no method on trusted len.
yeah, so this is a good example of what I was going to say, which is that we don't currently have a way to make a trait that is like conditionally unsafe to implement, which is I think what people sometimes want. So like they would want something where it says, if you don't implement size hint, iterator is safe, but if you do, it is unsafe. And that was the idea of trusted len, was to kind of to work around that essentially. So, but I think we should just go, like, I think I've changed my mind on this in the past, but I think I was just wrong. It seems pretty clear to me that the Scott's understanding is sort of just correct. And the language, people may use it another way, but that feels wrong to me. And maybe we should try to provide them a better tool than like a conditionally unsafe trait, or at least just talk more about the pattern. You know, I think unfortunately you need specialization to make the trusted len pattern really work.
So I want to make sure I understand what you're saying, Nico, in terms of Scott's understanding versus the example of trusted len. Is your point, so because Scott's understanding...
I don't think trusted len is contrary to what I said.
Okay, that's important. Okay, because yeah, to me, unsafe trait and unsafe impulse of unsafe traits is mostly a statement of there's a broader protocol here that's, you know, requires analyzing not just this impl perhaps, but other stuff. And trusted len is the case of
we
that.
have a bunch of examples of unsafe traits that are, well, I guess maybe a bunch is overstating it, but step became unsafe as well because we can't say that something, because step, we use the definition of things in the step trait that are themselves safe, like please add one. And the unsafeness of the step trait is you promise that actually does add one and doesn't do something stupid.
Yeah.
It's sort of, we've had a whole bunch of things down this line of like, people have talked about trusted ord for your sort is actually, your ord is actually an ordering, not some garbage, so that we could actually rely on it in sort, because apparently you could make sort like 2% faster by trusting that or something.
Yep. I mean, I think the fact that the caller needs an unsafe block, just doesn't make sense if all it means is that, like, the impl had to meet some additional proof obligations.
Yeah. I think the other way we can look at this one is look at our other uncarried effect, which is const. You could also have a similar RFC that said you can define the impl of the method in your trait as const, even if the trait itself didn't say that the method on the trait was const. Like you could imagine saying, hey, I am impling default for my thing, and the default method is a const fun, even though the trait does const fun. Now, I don't know that we want to do that, but as an example, it's sort of the same thing to me of my impl is allowed to promise something stronger than what the trait actually said it was.
This seems a little more complicated in the context of const, because the additional property you would want for const is if your function is a const fun and you declare that your impl of the trait is const handwave, then you should be able to use default as const, but that's kind of almost creating a parallel trait hierarchy.
Yeah, well, I don't know if, I wonder, for example, for the unsafe thing as well, if the method is unsafe, but the implementation is not unsafe, can it be called from safe code without an unsafe block?
Does the RFC...
It's sort of the same problem as can you call a trait impl that says this method on it is const from a const context? And that has a whole bunch of semver weirdness and stuff as well, so.
Right, I believe the RFC here may have punted on the question of if you know what the type is and you know its implementation has a safe fun here, can you call it without an unsafe block? I think that it just punted and said, if generally speaking, you know that it has the trait, and the trait says it's unsafe, so you have to assume it's unsafe.
Yeah.
But yeah,
maybe that's why I remember that example, because it was in the RFC.
Yeah.
No, there is an interesting example here of an analogy to const, which is that not unsafe is almost a similar parallel hierarchy of if you want to call it using what's in the trait, then you can. And the fact that you're allowed to omit unsafe, meaning make it safe, is similar to the idea that you can add const. In both cases, it means you're implementing something slightly stricter than the trait. And in theory, you could ask for impls of that are compliant with the stricter version.
All right.
But that's getting back into impl const default and all that sort of stuff as well. So
from what I can see, the RFC does specify that when the trait's unsafe method is called on a specific type where the method is known to be safe, the call does not require an unsafe block. That is. So.
Yeah, that would be a. I'm sort of inclined to. I don't know. I guess I was going to say to close this RFC, but not because I disagree with it. I actually like it, although I don't know how I think about that last part. But I do want to say there's another precedent here, if I remember, which is that I think you're allowed to have region or lifetime annotations that are more accepting than like this says it will.
Oh yeah, that's a good point. That confused the crap out of me when I found it out the first time.
Yeah.
This is a covariance, contravariance kind of thing of you're allowed to be more accepting than your parent trait.
Right. And
yeah, you're allowed to accept any lifetime instead of the lifetime from the trait, for example, if you don't actually care.
So you could, for example, also say, no, I'll take something that's static rather than something that has to be limited.
Yes.
No, other way around, I think, but yes.
Right, right.
And we actually used to do what the RFC proposes and actually take advantage of this when type checking, but we stopped doing that at some point because it was a pain in the neck. I don't know if I like that part of the RFC. I think I'd probably go one step at a time, but just because there's implementation considerations and I'd want to wait until we've got a nicer, cleaner setup for how we handle all that stuff. But
Well,
minor
and-
nit. I'm assuming the example here should have two different argument names.
sure, yeah.
I also think the Sember thing there is a little interesting because if you do implement it as to do, you probably forgot to write unsafe. And then if you,
Right.
or as unimplemented or something, then it would be a breaking change to implement it as an unsafe fun. Even though the trait was an unsafe fun the whole time.
Right.
So
Yeah, that's
I
a
don't know.
good point. In the case of const, the same would be true if you went from it being const to it being non-const. That would potentially be a breaking change. But on the other hand, that's part of why we've talked about having you write it as like impl const something rather than just filling in a const fun in the trait and having that magically propagate.
So I'd like to move us a little bit forward. Does someone want to summarize any of these points on the RFC thread?
Well, what is our consensus here? Do we want to close this on the basis of yes, technically, but we don't think the syntax is important here, or do we want to consider accepting this?
I wouldn't want to accept it in its current form because I don't think I want to necessarily allow the caller to take advantage of it, or at least I'd want to think about that.
I feel like maybe we're at postpone for cleanliness as a maybe mentioning the analogy to lifetimes as this is kind of interesting, but we're not actually going to do it right now, or
it's not like it's hard to implement at least the first half, but I mean, if we just allowed it to elide the unsafe keyword, then we do definitively declare the meaning of unsafe on a method, and we don't get ourselves into any Semver hurdles yet. I guess, well, maybe we would want to do that in one step, because if we tried to later make it something you can take advantage of, then we're sort of changing the Semver meaning of existing code.
oh, that's a good point. I don't know. I think I feel like we're getting to postpone, possibly interesting. We like the idea, but we're not sure, and we're not going to do it now.
I would agree with postpone. I would also say, given that we just talked through and managed to figure out a very difficult question of, or at least a non-well documented question about what does unsafe fun mean versus what does unsafe trait mean. I agree completely with Scott's interpretation of that. I think that was not at all obvious and we should document it. So even if we're postponing the RFC, I think it is worth explicitly documenting that that was the consensus we agreed on and putting that somewhere. Could we add some documentation somewhere? To the documentation of unsafe trait?
I think the language reference might be a good place for that.
Yeah, exactly.
Yeah. If it's not already in there, which it might be.
I can take an action item for that.
Okay.
Try and type what I wrote. Type what I said
Yeah, I
earlier.
think you'd be the perfect person to write that up and to give an example of it.
Conveniently, there's a recording, so I can even remember what I said.
Very good. I will remove, well, no, I'll leave the nomination until you can remove it when you write a comment.
Oh, so am I signing up to write a comment and
you are
postpone this as well? Okay. Deal.
So, anything on this RFC list that's surprising to people? Let's talk about this Const generics project charter. So we have a few. The current process is that creating a project group is a kind of commitment on the part of the Lang team that we think this is a good idea. And so we decided to run with RFC bot FCP merge. And this is the first instance of trying that. I guess Bastian is here, but this is the Const generics charter. The idea is to make a project group that will pursue Const generics, starting with the goal of this minimal subset and working out what we feel, whatever they / we feel is necessary to feel confident in stabilizing that subset. And then I guess once that's done, we can decide if we're going to keep going or if we're going to sort of what's going to happen next, how active it's going to be after that. Does that sound right, Bastian?
Yep.
I don't think in this case there was no MCP and at least no Lang team one, but that's okay. We all got the idea. There was a bunch of other stuff. So check your boxes if you're good with that. I think one thing that's not in this charter, by the way, is the initial people involved. So maybe we can talk about that offline. But I think the plan was, Bastian, that you were gonna lead it. I would be willing to liaison, I guess. And maybe boats. I don't know. It's boat's story. But
I saw Boats have a bunch of comments on the IRLO thread about this stuff. So
right, boats are certainly following along, so that's good. But they're not so active in the meetings, so they may not be a good liaison per se, as opposed to just somebody involved in the group. But I would like to follow along and be involved, so, or at least be tracking what's happening. Let's put it that way. All right, then let's move on to these pending project proposals. So there's we didn't really like figure out a good way to stay on top of these, and I want to not let them just become, you know, something that's where we have a huge backlog. So I wanted to try and get on top. My thought was that we could look at these and try to write up, like answer a few questions about them and or leave some thoughts. And basically what we should leave with this meeting is either a sense that we like do or don't think this is a good idea, or maybe some suggestions for possible liaisons, in which we have some, they may or may not, like we have a kind of short list of possible non-Lang team people we thought about, but if somebody comes to mind that would seems good for a particular RFC, then we could discuss it. Does that sound fine? We'll start with this one. Actually, no, we won't. We'll start with the oldest one. Well, here's the ultimate oldest one, which was something by me. I still think this is probably a good idea, but I think I'm just going to close it unless somebody, because I don't quite know how to advertise the, like, I want someone else to run with this. You know, this doesn't
Can
seem
you
yeah.
elaborate a little bit on it?
Yeah, let me give a brief summary. So the idea was that it would be useful to have a trait that's kind of a magic trait called function pointer or something else. There are some variations that came up in the discussion that's implemented for all function types, all FN types. And the reason is that you can't write an impl that applies to all those types, and we have no features that would enable you to do so, because you can't be generic over ABIs or the number of parameters or the kind of lifetime bindings. But and we frequently find things like people who want to treat function pointers as kind of integers, basically, like ord or partially q or clone, all these different traits. Right now, I think a lot of those are built in the compiler, but the hope would be that if we have a built-in trait that's fundamental, that's important, then you could write more of this stuff in library code. And what you commonly see today is stuff like this, where people kind of implement for all the possible variations that they can come up with, or this one, you know. So I guess we don't actually build it in the compiler. I don't know. I think we do for copy and clone because we absolutely have to. But so one problem is that one motivation here is that we're working on improving how the compiler handles higher ranked lifetimes, and some of these patterns may stop compiling that they compile. So it would be nice to have something for people to move to in that case. Because some of them only compiled by accident, kind of.
Proposal is meant to include higher ranked lifetimes, like for lifetime function.
Yeah, I view that as part of the FN type.
It didn't show any examples of that, at least explicitly, so I was curious.
Yeah, but these examples,
It's implicit. Okay.
it's sort of implicit, yeah, but yes, it is meant to include that.
But this
Okay,
is
that's
only-
interesting because that's more than variadic generics then. Sorry, Josh, go ahead.
That's right.
No. Go ahead, Scott.
I was just saying, so the part I had missed about this was the four lifetimes, because otherwise it sounded a lot like variadic generics.
Yeah, that's actually what this sentence it probably didn't convey, but was meant to mean, where binding occurs. Yeah,
I will also say I've wanted generic over ABI several times in terms of like somehow being able to actually address the ABI as a generic parameter. But it sounds like this is only dealing with FN. It is not dealing with capital FN once or FN mute or any of those.
So there were some variations, I forget the details, that was discussed about how we could possibly include some of those. That's a little harder. Like you could include closure types, maybe. It's a little harder because closure types would be okay, but if you wanted to implement it for arbitrary types, I think there's some, why do I have concerns? Well, yeah, I don't, if it's some, today you can't manually implement FN and FN mute and so on, but eventually I think we would expect you to be able to, and I don't know.
Right.
It would play well to, would basically let you detect in some coherence weird kind of way. I guess those traits are already fundamental, so maybe that would be fine. But anyway, it's something we could explore. Like I'm not too wedded to the details. There was like I said, some people had some proposed changes that would allow you to do a little more than just get an integer that represents the function. I think partly to address wanting to be generic over API in some cases. But I don't think we have any proposal that lets you call the function. You'd have to pair it with an FN trait to do that.
Right. So presumably having anything that would let you actually call the function would require full variadic generics.
Yes, and moreover, like you kind of can't do that. You can't call the function without knowing what its signature is, right? And the point of this is to let you write code that works for any function regardless of what its signature is. So
I think part of the answer to why not capital FN is that it has an as usize method in the trait,
yeah,
right?
but you don't have to do it that way. You could also include other methods that let you like compare and so on. But it would, but yes, that's part of the reason. Like instead of exercise, you could have a method for ORD and a method for EQ and stuff like that.
Part of me sees safe transmute and then turn it to a usize thing.
Yeah, possibly. But do you ever really want to implement ORD for all things that can be made into usizes? Probably not. But you do want to implement ORD for all function pointers. So I guess in terms of our, in terms of this stuff, I would say the motivation is not too strong or sort of medium. I don't know, maybe weak. Like it's a problem. It's one of those problems that doesn't affect a lot of people, but it's annoying when it does affect you. But it doesn't solve all the related problems. It doesn't really correspond to our priorities, I wouldn't say, except basically, if the compiler is making changes that break people's code, then this goes up in priority, and because of that. Until then, it seems fairly low. That's my take. Does that sound right.
How much of this is stuff we want to use in core versus other people to use?
I don't know. It's probably mostly core, but there's definitely certain patterns of where people implement this. Like, what was this?
Yeah, I'm just imagining like if it could, something like this could exist like for use internally so that we can have function pointers that work nicely without
Right.
any lang team action.
Yeah, we could certainly
And then,
add, it would need still some lang team action, but yeah. This is kind of a commitment to that happening, but yeah.
oh yeah, sure.
Could just do it as a implementation. That was probably where I would imagine this would end up being sort of semi-unstable for a while until we decide what's happening. But,
Well, and if it exists unstable, people could experiment it with it and go, oh,
Right.
no, this was wrong. Or, oh, yes, this is exactly what I needed.
I don't want to spend
Having
too-
it available as an unstable experiment seems worthwhile if it's really easy to implement. I do think that there's long term, we really want some kind of overarching fun trait that takes these things into account and can give you pointers and can also let you call things and similar. But that would wait on periodic generics, and it's a question of, do we want how urgently do we need this intermediate step?
Yeah.
So let me try to summarize these points. There is a problem here solved, but it might be nice if we were able to permit more operations than just treat as it. By the way, I saw some notes here that it looks like you could also just support as usize, but it would cause us to reify the function pointer, which would be kind of neat. But yeah, maybe. I agree that that would be nice, all things being equal. I don't know, but then if the compiler changes wind up sort of breaking people's code, this goes up in priority. And we could implement it as an unstable implementation detail in libstandard to experiment in the meantime. Otherwise, we're going to close. That sound right? I think we're going to do that. I want to move to another one. I'm closing it. It's my thing. Maybe we'll open it later. So the next oldest one, Portable SIMD project group. So some background here is that Henry Savonin has been trying to encourage us to get Portable SIMD for quite some time. There's a lot of details here in this, which I won't go into, but basically the idea is that LLVM supports kind of SIMD that compiles down to different targets in different ways. And there's this packed SIMD crate that exists where people are trying to take advantage of it using some unstable features. Is that right? I think so. Currently it works by being generic over array types, I think, as you can see here. And so the proposal is to explore this and see what it takes to support this in Rust. There's a lot of detailed background. Some hands up and hearts. I think I want to see this work go forward, but if we jump to my little then maybe I'll try typing in some of this. Now we're almost out of time, but maybe we have time for one more. But I'm concerned that we don't have we have to figure out who the right people are to work in this group, because I think there have maybe been a few different approaches over time. And I'm concerned we sort of don't have the like available bandwidth to really manage this work very well. So I would sort of be inclined to either close or if there's, or maybe postpone someone's queue of like who will get to it. But I'm curious to hear what other people feel.
It feels like there's massive libs interaction too here.
There is, yeah. This is a lang libs cross-functional thing where we really couldn't proceed without both, I think.
That's a really good point.
Like,
I also think we very much need the right stakeholders from different thoughts on how to deal with SIMD. I don't know how to quantify that. I'm just saying we need to have the right people in the room to make this a successful discussion.
oh, especially with all the weird things like the variable length SIMD things that some people are doing, right?
So I do actually agree entirely with that aspect of this particular proposal in charter, that there's a lot of things to be, a lot of variations on how you could do SIMD, but I think that having fixed width SIMD at various specific widths is valuable, and trying to do full variable width SIMD is something that should be handled separately. I think
That
there's
sounds fair.
value in both. I think there's value in both, but I think the proposal here, as far as I can tell, is we should have 128-bit SIMD, 256-bit SIMD, and so on, and we should just implement it everywhere we can, even if we have to polyfill the 256-bit on places that only have 128-bit and so on. And I think
Right.
that is the right approach. I think that's
I don't know.
valuable.
Yeah, that would be good. I'd be very happy to have it.
So
I think the primary concern here would be things like, it's a lot of little details, like what are the correct vector types to use? Would they be compatible with the types we already have? Can you move between them without needing a transmute? Could you share the types in the first place? There's a lot of little things to get right, and I feel like one of the stakeholder questions here is, are we having that discussion? Do we have the right set of people who have the experience with what's in the tree and what's out of tree to have that discussion?
one thing I was wondering about is in terms of our declared priorities, which admittedly, I don't know. Josh and I were talking earlier, and I think it best fits in this category, even though it's not C parity or interop or embedded. It's kind of a specialized, I think what I actually view of this category is sort of like exposing capabilities that are really important to some people and not at all important to those people who don't need them. And SIMD fits my mental model, fits that description. But you know, the fact that it's not actually on our list is also like a somewhat lowers it in my view. Like it's not a perfect fit. Now that doesn't really mean anything because we made up those priorities, but I mean, it means something, but maybe we feel like it's so important we should do it anyway. But
So, random thought here. What exposed from a like language semantics perspective happens out of this?
I think I think it builds on some intrinsic operations. Maybe this is what we should.
Right. I'm just imagining that, you know, you could define a type that was called SIMD F32X4, and
maybe not.
it's defined in a certain way. It has addition that works pair by pairwise, etc. And the fact that it happens to use a SIMD instruction is a quality of implementation issue, essentially, not actually a semantic one.
So there
Obviously,
is
it should use the SIMD instruction, but
right.
Go ahead, Josh.
So there's actually an interesting notion here. On the one hand, you could do this by using entirely the architecture intrinsics that are already exposed and implement this entirely as a library. And if that
Yes.
were the case, then this wouldn't really need any Lang support. The other approach, and the one that this is proposing, is to use LOVM intrinsics that are in some way portable-ish and are designed to compile to the right instructions on different platforms rather than re-implementing those LOVM intrinsics. The upshot is we don't have to re-implement a bunch of intrinsics. The downside is we depend on the LOVM intrinsics, which are inherently unstable and nightly only and probably always will be. And as far as I can tell, the primary motivation for this proposal was, well, we want to keep using the LOVM intrinsics, which we know will never be stable, and we want to be stable, so let's become part of standards so we can use nightly and be stable. And
Right. So
I think as a motivation goes, I'm thinking that's not the ideal motivation for putting something in standard.
So I see it. So I don't disagree with anything you said about the implementation possibilities there. I'm going to make two statements about that. First, if from a observer's perspective, you cannot tell based on using these portable SIMD types whether they are implemented using LVM intrinsics or the existing architecture-specific stuff with CFGs, then I could make an argument that this isn't actually a Lang question at all. This is a like libs impl question, and libs should define a format that they want, and then it will be implemented in an appropriate manner, and that's fine. I think the bigger argument for I don't think it's that I want to use, I don't want this because I want to use the SIMD instruction, the like LVM SIMD vector types internally. I want this because I don't like using intrinsics and I would like to use, you know, the add trait to add things or something and have a rusty API on top of all this that doesn't look like the intrinsics and isn't platform specific so that I can just write code and have it do a good thing.
So it's 4 o'clock and,
Oh, so it is.
Here. I don't know what's coming out of this, but it seems like we had some good thoughts, a lot more feedback. It'd be great if someone could write some of it up. But I'm kind of circling back to, do we have a liaison and how strong do we feel motivated? Like it seems obvious that there's a lot of discussion to be had. Maybe we'll revisit it next week, but I think those are the questions we have to put a little thought into. Is somebody, I guess it's both, is someone passionate enough and have time and energy to help work and see it through, or slash, does anyone feel like, even if someone is, that it's too much work or not, there's something that's going to have implications for the rest of the team that would hold it back.
It feels to me like Lang questions here are basically non-existent. Like if libs can come up with an interface that they think is like the right way to do all of these things and is implementable, then it's fine.
I would be fine with let me rephrase that carefully. I would be fine with the notion that the Lang team could provide a consensus explanation of discharging our stake in this and saying, like, as long as X, Y, and Z, we feel comfortable completely, handing the rest of this to the libs team and just hearing back when it's done. Like, our requirements are related to the use of intrinsics and the potential exposure of those intrinsics. Beyond that, we're not especially concerned. So we're happy to delegate the rest to libs. If somebody wants to put that into the comment, I personally would agree with that. Any other thoughts on other Lang team considerations there?
I'm sort of trying to square that with your earlier statement that there's lots of details to get right and so forth, but you're saying those are more libs details than Lang?
There are a lot of details to get right, and I do think most of them are technically libs.
Okay, I would say this also does tie us to LLVM. Like,
Yes,
you're pretty strong
that is a lang consideration.
in a much stronger way than many other things.
Is it a lang consideration or a libsimple consideration?
Well,
In some ways, it's
they're
almost
fairly
a compiler
close, but
consideration, actually.
yeah.
it's an overall-
But the idea of being tied completely to LLVM, so I think that's where I would put that is it's a quality of implementation thing, but if the implementation is such that it can't work anywhere but LLVM, then there's a consideration there beyond libs.
Yeah, it certainly ties us to being able to lower arbitrary vector sizes to an implementation that works.
I feel like it's sufficiently fundamental that it's lang.
My just feeling here is that semantically, if you just did this as I call plus 4 times, that would be a bad performance implementation, but a semantically lang valid implementation.
And probably one that should be available as a fallback for use on arbitrary platforms without any support, or at least you should be able to opt into that.
Which hopefully LLVM does already, but I feel like that is something that we could do relatively straightforwardly, regardless of what implementation we're using in the compiler at any given time. Like if we don't have SIMD and WASM yet, and we emit this as just a bunch of pluses, then great.
All right. I think we got to end this call. I'm not sure what the takeaway is. Maybe there just isn't one yet. But I think this idea of we should think about. I'll try to post a summary. I'll volunteer for that. But in particular, weighing the idea of maybe we can ping the libs folks and see if they're interested in what they think. If there's somebody that they also might have an idea of like what other approaches are out there. Okay, thanks everybody.